Hi guys, and welcome to a video on the General Maths series here for MaffsGuru, and that's strangely me. My name's Darren. Thanks very much for watching. If you haven't already done so, can you head over to MaffsGuru.com? Look, basically all the videos are there, and they're sortable by textbook and by chapter with downloadable notes. Could it be any more exciting than that? And if you can just click on that little button that says subscribe to my YouTube channel. I'm never going to be rich, and I'm certainly never going to be famous, but you never know, there might be a day where other people will find these videos rather than the 4 people I currently have subscribing. All right, so what are we looking with today? Well, basically, we're going to build on the understanding of what a ratio is and understand that we can basically simplify ratios. These are huge tricks that we use in mathematics because what is maths? Nothing more than a smoke and mirror. Now, yes, we're recapping. This is sort of a preliminary course, as it were, for general maths, where we're going to do all the sort of funky stuff or the sort of easy stuff that'll be built on in the rest of the course. So what is a ratio? A recap. Now, we looked at the idea of a ratio as a way of sort of grouping people or comparing numbers or having some mathematical way of sort of describing them. So in a previous lesson, as I say, we looked at the idea of how much one thing is compared to another. So in a year 10 class, 26 students, there were 14 girls and 12 boys. So automatically we can see that girls and boys are the things we're trying to compare. Now the order of ratios is really, really important. And it says express the number of girls to boys as a ratio. Now because it says girls to boys, I'm going to write girls dot dot boys, and then quite literally the number of girls, I've got 14 and boys is 12, and that's the answer that we get. But that's not actually in its simplest form, yes? And this video is going to deal with the idea of actually reducing that into its simplest form. Now you've been doing this before with fractions left, right and centre, yeah? But just be careful that in exams you are expected to write these things in simplest form. And I've got sort of a slide coming up, and as I say, don't forget the notes are downloadable from MaffsGuru.com, where you can sort of cut them up and stick them into summary books or just write all over them or burn them, whatever is up to you, yes? Now, as I say, we've dealt with fractions. So the idea is if I had something like 2/4, every single one of you at this moment in time should be shouting at me going, well, no, that's actually a half. And of course it's a half. Why is it a half? Because we know we can divide the top number by 2 and the bottom number is also divisible by 2. Right? And when we cancel it down to a simplest form, the examiner seems to be happy, I'm happy, the world is happy, and life is good. I don't know quite why life is good, but life is good. So you've got to be able to make sure that you cancel these things down. I've got some examples here, and I suppose the big thing here is, do you know your times tables? And if you go, no, I don't know my times tables, well, you've got to realize now that you are nearly 147 years of age, and you can probably now learn them. Okay, you had trouble when you were 6. You're not 6 anymore. If you'd stopped learning when you were 6, we're in all sorts of trouble. So let's look at 3 examples here, and we'll start with 15 dot dot 20. What's the highest number that can go into those? Well, obviously using my fingers and my toes, I've worked out that the highest I can divide those by is 5. Now, what's important is you've got to keep the ratio the same. And what I'm saying is you've got to keep it equivalent, and that's sort of building on what we do with algebra. So what I'm going to do to one side, I have to do the other. Notice I put those little arrow signs on there. So I'm going to divide by 5. I'm going to divide by 5. 15 divided by 5 is 3. And 20 divided by 5 is in fact 4. And jobs are good. My ratio is 3:4. Now I can't take it any lower than that without getting decimal values or fractional values, and we try and stay away from those. Whole numbers is how we like to express, but in its lowest form. Hold on a moment, I just said you weren't allowed decimals. No, you're not really allowed decimals, but who's to say they're not going to throw one into an exam and try and trick you? Yes, indeed. Now, in this situation, I've got the ratio 0.4 colon 1.7. Now, when you have a decimal point, the thing to do is get rid of that decimal point. And what we notice is because we have one number at either side of the decimal, and what I'm saying is because there's one number of the decimal after there and one number after the decimal there, I can basically multiply both sides by 10 to get me to a much nicer state. All right, so if I multiply that by 10, I'm going to get 4. If I multiply, he says, doing an equal sign, so I get 4. and that becomes 17. And then of course I'm going to use my fingers and thumbs to try and work out what number goes into 4 and 17. And as it turns out, 17 is a prime number, and so it's only divisible by 1 and itself. So again, that is my final answer. I can't take it any lower than that. It's still in the same ratio. It's still expressing the same thing. So like if I had the ratio 1 to 2, for every 1 something I'm getting, you're getting 2. That's the same as 2 to 4 and 3 to 6. Those are all in the same ratio. What about the next one? Oh my goodness, fractions. We hate fractions. Well, no, we don't. All right, because again, we're going to try and work out, we've got 3 quarters and 5 thirds. Now again, what am I trying to do? This is where we go back to our fractions work before and go, common denominators. Can I get these on a common denominator? And I'm like, well, yes, you can. We can end up and put them on twelfths. Now, the great thing here is what I'm actually going to do is I'm not going to change the bottom number into 12. I'm going to multiply both of these things by 12. All right. Now, the reason I'm going to times them by 12 is firstly, we're keeping it the same. Remember with maths, what you do on one side, you do on the other. So long as it's equivalent, we're fine. But what do we notice happens now? Well, we notice that 4s go into there once and 4s go into there 3 times. And we know that 3s go into there once and 3s go into there 4 times. So what we now notice is we've turned those bottom numbers of my fractions into 1s, and all I need to do now is multiply the top numbers together. So I've got 3 times 3, which gives me 9, and then we do a colon, and 5 times 4 is 20, and lo and behold, there is my final ratio. And again, I can't simplify it any lower than 9 and 20 because nothing goes into 9 and 20. Now, as you can see here, there are rules of ratios, and these are 3 that is actually quite important to know. When ratios are written in terms of the smallest possible whole numbers, they're expressed in their simplest form. So what they're saying is smallest possible whole numbers. That's really, really important. The order of the figure in a ratio, the order of the figures in a ratio are really important. And as I say there, if you have 3.5, that is very different from 5.3. Because again, if we had the girls to boys, and we tried to see the same thing girls to boys, we would notice those are quite different. Yeah, here we've got 3 girls for every 5 boys, and here you got 5 girls for every 3 boys. They're not the same in any way, shape or form. And finally, both parts of the ratio must be expressed in the same units of measurement. And that's where maths throws people. That's where people get confused. Why? Well, look, as I say, just when it's safe to get back in the water, it's really not, because so many people get tricked with this question. They go, oh, I can do this. It says as a ratio in its simplest form. And they go, 15 colon 3. And my 3 times table means I can divide those by 3 to keep them equivalent. And 15 divided by 3 is 5. And 3 divided by 3 is 1. And I'm done. And yes, no. Why? Because we gave you different units of measurement. We gave you 15 centimeters and 3 meters. So sadly, that's all wrong. So what we now need to do is convert either from centimeters into meters or meters into centimeters. And it actually always makes sense to take the bigger measurement and turn it into the smaller one. Now, because meters is bigger than centimeters, I'm now going to change that to 15 colon and 300. Okay. So what goes into both 15 and 300? Well, believe it or not, 15 goes into both of those numbers. How did I know that? Practice. The fact that 300 starts with 30, and I know 30 and 15 go into each other. All sorts of different ways of doing it. Basic number skills, really. But what I'm going to now do is divide both sides by 15. That's 15 divided by 15 is 1, because anything divided by itself is 1. 30 divided by 15 is going to give me 20. And lo and behold, I can't go any further. Now, that, believe it or not, is about as tricky as it gets, yeah? The trick here is using your times tables and knowing how to find things and whatever else, yeah? So, as we say, we can also go in the reverse process. I did a little bit of example this a moment ago, but yeah, what we can do forwards, we must be able to do backwards. So, as I said, we had a ratio of 1 to 2 before. Can I change that? Can I make it bigger by scaling it up? Absolutely. I can times that by anything I like. I can times by 4 on both sides, and that's going to give me 4 colon 8. It's exactly the same ratio. For every 1 of something, I'm getting 2 of something else. If I give you 4 sweets, I'm going to have 8. If I give you 1 sweet, I'm going to have 2. We can group them all in this way, and that comes up a little bit later on. What else can I write 1 to 2 as? I could multiply by 10. to give it 10 to 20. I can multiply it by 20 to give 20 to 40. So long as what you do to both sides is equal, then jobs are good. Not a problem in any way, shape or form, all right? So here's an example now where they give you two equivalent ratios. And what they're saying is 3 colon 7 is equal to something colon 28. Now, I tend to write these in a different way. I tend to go 3 colon 7 and question mark colon 28. I always write them underneath each other. Why? It just makes it easier to see what my ratio is that I'm trying to find. I've gone from 7 and I'm going up to 28. Now, obviously, because we're dealing with ratios, this is going to be a times by question or a divide. I'm looking for something that times by 7 to give 28. Okay, that's 4. So I'm going to times that side by 4, which means I must have times that side by 4, and 3 times 4 gives me 12, and so my missing number is 12. Ka-ching! Yeah, again, there's lots of ways of doing it. I could have just gone, well, 7 has gone to 28 that way, so what can I do that way? You don't have to write them in columns, but I tend to think for things like the unitary method and stuff that comes a little bit later in the course, it's really important to you. Okay. Now we can use the CAS as well, and you may notice that I have now gone from the Casio to a TI Inspire. That's because I've changed schools, and as such I've changed calculators. So, and apparently the TI Inspire has the market share. Sorry Casio, but I'll do my best to do the Casio examples as well. Now we can use our Casio to think of ratios, or our calculators to think of ratios in a different way. What we know is 3 to 7 can also be thought of as a ratio going that way. And question mark to 28 must have the same ratio. So what I'm saying is that 7 divided by 3 must be exactly the same as 28 divided by the question mark. So that's one way of thinking about it. Funnily enough, we could have done it the other way and said that 3 divided by 7 is exactly the same as question mark divided by 28. There are so many ways of thinking about it, but if I zoom in now to this screenshot, what do we notice? I've banged into my calculator different ways of doing this. Yep, so 3 divided by 7 equals x divided by 28. That was one of the examples I just did a moment ago. Solved for x and I got 12. But likewise, I could have done 3 divided by x is equal to 7 divided by 28. I chose x because my calculator didn't do what? What did my calculator do? It doesn't do question marks, funny enough. So the point of it is, ratios are funky. I actually practiced this. If you've got the textbook loaded up, have a go at some of the questions. But believe it or not, that's the end of this video. Thank you very much for watching. Hopefully it was useful. If not, play it again. If you can, give me a shout out to your mates. Go head over to MaffsGuru.com, sign up again for these downloadable notes and whatever else. And yeah, I'm done. See you in another video. Take care, guys. Stay safe.